Electricity, if not properly installed and not properly used, could mean injury, harm, or even death. So, what safety measures should we follow to prevent injury or an untimely death? What are the electrical devices that can protect us from a sudden surge of electrical energy? Let's check out on this video lesson. Electricity is a powerful force, and it's no surprise that electrical safety usually comes up in conversation when work safety topics are discussed. An electrical hazard is one of the most dangerous threats workers can face. It's estimated almost 5% of all workplace fatalities result from electrocution. Electrical hazard or electric shock is a condition due to direct or indirect electrical contact with energized conductor or equipment, and from which a person may sustain electrical injury from shock or damage to property or both. When working with or nearby electrical installations, an electrical shock, arc flash, or arc blast can occur, and current can go through the body due to the following situations. 1. Direct contact with live parts of the installation. 2. Accidental contact with damaged wires that are seemingly not live. 3. Direct contact with a grounded surface. That is why working with electricity requires a skill of a person who is trained for this type of job. Electric current damages the body in 3 ways. 1. It can cause improper function of the brain and heart, which may lead to cardiac arrest or death. 2. The body will experience intense heat that can cause skin burning. 3. Muscles will involuntarily contract, which will be hard to control. Dry skin has a resistance against current over 500,000 ohms, while wet skin has only 1,000 ohms. It is lowered once that you have bruises or you have damages on your skin. However, once the skin breaks through, for example, by burning or wire piercing the skin, the body will have 500 ohms resistance. So as you can see, again, if you have dry skin, the resistance against the current is over 500,000 ohms. That is reduced once that you have wet skin to 1,000 ohms. But once that your skin breaks through, if you have burns or if you have tears on your skin, your body will only have 500 ohms in terms of resistance. That is why it is not advisable for us to hold any electric appliance once that our hands are wet or any parts of our body. One of the common problems that is encountered when it comes to electricity, and when there are problems such as fire, the common cause is faulty electrical wiring. It is the one leading cause of the fire. The warning signs are as follows. 1. Lights dim or flicker when another appliance is turned on. So once that you observe that if you turn on or use another appliance and it affects another appliance, such as when your lights gets dim or it flickers, that is already a warning sign that you have a faulty electrical wiring in your home. Next is appliances do not have permanent outlet. Number 3, when you have many extension cords utilized in your home. Number 4, fuses blow or circuit breakers trip frequently. That is why we need a constant check on our home circuitry. Circuit conditions with faulty electrical wiring. Number 1, short circuit. So let's analyze this picture. So you have here the voltage source, the conducting wires which are open. So if the wires are open, it is prone to short circuit. Short circuit refers to a circuit condition in which a current takes the path of less resistance or zero resistance. Short circuits occur when electrical circuit wires or wire connections are exposed or damaged. When these wire connections that is exposed or damaged gets in contact with one another, it may heat up and it can cause fire. Next is grounded circuit. So as you can see, there is a man holding a refrigerator and he is standing barefooted. Grounded circuit refers to circuit condition where current traveling from the positive conducting wire bypass the negative conducting wire and flows through the metal casing of an appliance instead as shown in the figure. So that's why it's a no-no to hold any appliance if you are barefooted. Always wear your slippers or shoes. So for electrical safety devices, we have the first one. Are you familiar with that electrical device? Okay, that is called a circuit breaker. A circuit breaker is an automatically operated electrical switch designed to protect an electrical circuit from damage caused by excess current from an overload or short circuit. Usually, each circuit breaker controls a specific flow of electricity in our home. Let's say, for example, one circuit breaker for the lights, one circuit breaker for the socket, and so on. Its basic function is to interrupt current flow after a fault is detected. Next is, are you familiar with the picture flash on the screen? Okay, that is called a fuse. Fuse is an electrical safety device that operates to provide overcurrent protection of an electrical circuit. Its essential component is a metal wire or strip that melts when too much current flows through it, thereby stopping or interrupting the current. So in electronics and electrical engineering, a fuse is regarded as an important device in an electrical circuit. Its essential component is a metal wire or strip that melts when too much current flows within the system. For instance, if a fuse is rated at 20 amperes, it will pass that amount and it will melt to break the circuit. This blowing out of the fuse prevents the overloading in circuits that may result to fires. A small fuse, like the one the picture that is flashed on the screen, is a sacrificial material in an electrical design. It was designed and placed in a circuit to interrupt excessive currents so that further damage by overheating can be prevented. Next is an AVR, or an automatic voltage regulator. I know that you're familiar with it, especially if you have desktop computers in your home. AVR is an electronic device that maintains a constant voltage level to electrical equipment on the same load. The AVR regulates voltage variations to deliver constant, reliable power supply. Then you have UPS, or an interruptible power supply. It is an electrical apparatus that provides emergency power to a load when the input power source or main power fails. For electrical safety measures that is recommended, one is called earthing or grounding. So analyze this picture flash on the screen. So you have here a metal strip on top of the building, then the wire, then you have the underground rod. Earthing or grounding is a system of connecting the metal casing of the appliance to earth. Earthing protects the user from a grounded circuit. The second one is called double insulation. So as you can see on the picture flash on the screen, the conducting wires have double insulation. Double insulation is a safety measure done by appliance manufacturers to prevent electric shock and grounded external casing of appliances. With double insulation, live wires within the appliances cannot touch the casing even if wires become loose, thus eliminating the need for earthing. At this point, let's check your understanding. Number 1. Safety-related work practices involve A. The use of ground fault circuit interrupters. B. Verifying power is off before doing repairs. C. Keeping proper distance from overhead power lines. And letter D. All of the above. So among these choices, which is considered as safety-related work practices? Okay, for number 1, the answer is letter D, all of the above. Number 2, how do you prevent from experiencing electric shock at home? A. Recycle blown up fuse. B. Regularly check household wirings. C. Plug electrical appliances with wet hands. Letter D. Continue using worn out extension wire. So how are we going to prevent from experiencing electric shock at home? The answer for number 2 is we have to regularly check our household wirings. Have an electrician check your home circuitry. Number 3. What safety measure has been done by appliance manufacturers to prevent electric shock and grounded external casing of appliances? A. Grounding. B. Using AVR. C. Double insulation. Letter D. Using circuit breaker. Okay, for the answer for this question, we have letter C. Double insulation. Number 4. Which situations shows that current could go through the body? A. Direct contact with a grounded surface. Direct contact with live parts of the installation. C. Accidental contact with damaged wires that are seemingly not live. Letter D. All of the above. Okay, for number 4, the answer is all of the above. Letter D. And for question number 5, which of the following directs any excess current in the metal casing of appliances to the ground? A. Fuse. B. Earthing. Circuit breaker. D. Electric socket. Alright, for number 5, the answer is letter B. Earthing or grounding. So thank you for watching this video lesson. See you again next time for another science lesson.